Let's move on to part 4 of AC bridges. Starting off with Owen's bridge, this is your required circuit diagram and phasor diagram. We are trying to find out the unknown inductor, from a known capacitor over here. Once you balance this bridge, you use these two formulae to calculate your unknown R1 and L1. Now this method has certain advantages, like these R2 and C2 happen to be in the same R, so balancing this bridge is not at all time consuming. It takes very less time. Now the balanced equations are rather simple, and one more thing, wide varieties of inductances can be measured through this Owen's bridge. Now it has certain disadvantages as well. This variable capacitor over here is rather expensive, and for measuring inductance of a coil whose quality factor is high, the value of capacitance gets very large, so this is a disadvantage. Now what we are doing is we are using this Owen's bridge to calculate the incremental inductance. These are your coils. This is air core and this is iron core over here. Let's get to the terminologies. Mu r is relative permeability of the core, L is the number of turns, Mu naught is the permeability of core, L is the length of coil, A is the cross sectional area of the coil. Now this is your core. This is your relative permeability. In an air core it is equal to 1, N is the number of turns over here. So this is easy. You use this formula and find it out, because there is a linear BH curve. So here you don't have any problem. The method is simple. But for finding out the inductance of an iron core, that has an iron core, you cannot simply use the formula. The relationship is not linear in nature, and this BH curve induces some IDC. This is an undesired component. So what we are doing is we are trying to eliminate it. How we are doing is, let's see. This is due to hysteresis. This is your hysteresis curve. Now what we are doing is we are adding additional DC source to compensate your DC component. Then we balance the bridge. This is the modification. You see the old circuit. All the arms are same, only one thing is added over here. This thing is the modification over here. This is your additional DC source to compensate your IDC component. And then you use this particular formula over here to calculate your inductance. This method is used for iron core only, but when we have to find out for air core, it is not difficult. You simply use the formula and get the answer. So this is all for part 4.